Now let's continue this example. This is we still consider x squared plus, x squared plus y squared equals 9. And then we know this is actually a circle with radius 3, right? And we also know there is a point, which is the point P is 2 square root of 5. This point is on the curve, right? So we have calculate. So we want to find the tangent line. Through this point, through the point P, which is 2 square root 5, right? We have calculated, right, the slope, the derivative dy over dx, which is the slope of the tangent line, which is given by negative x over y. So we write down here. Negative x over y. Okay, so this is the slope of the tangent line at any point. So what is the slope of the tangent line at the point 2 square root of 5? So 2 square root of 5, that means x equals 2, y equals square root of 5. So we can do that. We can evaluate this slope at the point 2 square root of 5. We evaluate this slope at the point square root 2 and the square root of 5. So this would be negative 2 over square root of 5. Right. So this is your slope. So we have the point, we have the slope. We can always find the equation of the tangent line using the point slope form. So the equation of the tangent line is what? Y minus the point, have y equal to the square root of 5 equals the slope, which is, we just calculate, which is negative 2 over square root of 5 times x minus 2. So this is the point slope form. Okay, so this is your answer. Of course, you can continue to simplify the y equals something, but that we will not spend a lot of time on that. Okay, so now let's look at it. So we have solved several problems about the implicit differentiation, right? So you have some basic ideas. What is the implicit differentiation? So here is some remarks for the implicit differentiation. So you should be careful. So we notice that dy cubed dx is equal to, if y is a function of x, if y is a function of x, y is a function of x, so y is a y of x. So if we take the derivative about x, so we have to use the chain rule. So this is the 3y squared, then times the inside function is y, right? The derivative of y about x. So if we take the derivative for this one, dy cubed over dy, what's that? That is just 3y squared. Why these have different results? One has one more term, which is dy over dx. The other one has no dy over dx. The reason is the differential variable is different. Here, the differential variable is about x. here is about y. So you treat y as a function y, yes, of course, right? So here you treat y as a function of x. Here you treat y as a variable. So you have 3y squared. So you use the power rule directly, right? The similar thing you have is dy, the derivative about y for the function sine y. So we know it's equal to cosine y, right? But if we take the derivative about x for sine y, so that means you always treat y as a function of x. So this would be a composite function. The outside function is sine. The inside function is y. So the outside function is sine, the derivative about sine, which is cosine. Cosine of what? Of y, right? We plug in y. Then multiply by the derivative of inside function. The derivative of inside function is just the dy over dx. Okay, so you can see the difference. The difference here is because the differential variable is different here, is y, here is about x. So this is the reason we have when we take the differentiation about x on both sides, you will have some terms you will have some extra term because it's a differentiation about x. Okay, so it becomes the y becomes the function of x. You cannot just treat y as a variable anymore. You should treat y as a function of x. Okay. So now let's look at another example. So we have x to the fourth plus 8x times y cubed equals 10. We want to write dy over dt in terms of dx over dt. Okay. So now, so it's about the derivative about t, not about x anymore. So the idea is very similar. We treat x as a function of t. Y is also as a function of t. Okay, so keep in mind, x should be a function of t, y is also a function of t. So what we should do? We take the differentiation about t on both sides. So we take the differential about t on both sides. So the integration differential variable is t, not x, okay? So x to the fourth plus 8xy cubed equals dt of 10. Then we distribute the derivative because this is the summation. Plus, we can take the 8 out. Equals the derivative about 10 for 10. Constant equals 0, right? So here, let's look at this first differentiation about t. So x is a function of t. So x to the fourth, if you take the derivative about t, x to the fourth is actually a composite function. The outside function is the power 4. The inside function is x. So we take the derivative for the outside function power 4, which we use the power rule, 4 times something to the 4 minus 1, right? This is the power rule for the power 4. So what is here? Here it should be the inside function, which is x, times the the derivative for the inside function about t, times dx of dt, plus 8 times. So this is the product of two functions, right? One function is x, the other function is y cubed. So we use the product rule. So this would be the dx, the derivative about t for the first function times the second function plus the first function times the derivative about t for the second function y cubed equals 0. So let's do the calculation. This is the 4x cubed dx over dt plus 8 times the first, this is the y cubed times dx dt, right? Plus x times what? What is the derivative about t for the function y cubed? Remember, y is a function of t. Y is a function of t, right? So this is the composite function. The outside function is the cube function. So we use the power rule, which is 3 times something to the power 3 minus 1. So here should be the inside function is y, so we plug in inside the function y, and times the derivative of y about t. Then we use the chain rule again. Okay. Then we expand out. You will have 4x cubed dx over dt plus 8y cubed times dx over dt plus 24x times y squared dy over dt equals 0. We divide by 4 on both sides. You will have x cubed dx over dt plus 2y cubed dx over dt plus 6x y squared dy over dt equals 0. So remember, the question asks you to find what is dy over dt. So let's solve for dy over dt. So we move the other two terms to the right side. So you will have 6xy squared dy over dt equals negative x cubed dx over dt minus 2y cubed dx over dt. So dy over dt is equal to negative x cubed minus 2y cubed. So then we group together because they have the common factor dx over dt divided by 6xy squared. So this is your answer. Okay. So from this problem, if you know the dx, the rate of change of one variable, you can find the rate of change of the other variable about t. Okay. So this is called related rates.